Today we will see a GFG problem, job sequencing problem. It is a greedy based approach problem, medium level. Now in this, basically number of job n will be given, and the class job in which three values has been integrated. Like first one is id, second one is the profit, the second one is the deadline, and the third one is the profit. Okay, now second one is the deadline and third one is the profit. So the numbering is given like id is given as a 1 2 3 4, with the deadline as 4 1 1 and 1, and profit is given as a 20 10 40 and 30. So what we will be doing is, first we will sort this on the decreasing order of profit. So the first it should come like a 40. This profit is 40, so first it should come like this, then second 30 profit, and then 20, and then it should come 10, and then we will traverse uh, on the descending order of profit, and then we will check if the deadline is and we will store the deadline. Okay, and first of all we will check for the maximum deadline that is possible in the array. So maximum deadline is 4. Okay, so moving towards the problem statement. So what we will be doing here is, first of all we will sort this in descending order of profit. So arrays yes arrays dot sort arr, and in the descending order of profit. So in the place of the comparator we will be writing like a minus a comma b, that will be giving us, like if descending order it should be and profit. So p dot profit, a for profit. Okay, profit. Now this one will be stored in the descending order of profit. Now then we will be storing the maximum deadline value. First it will be initialized to 0, then we will move to entire till n and I plus plus, and then we will be checking if my arr of I dot deadline, it is given over here deadline. Okay, that same variable we have to use, deadline, uh, deadline. If it's less than dead, if my arr of our deadline is greater than the max, so maximum will be stored as arr of I, and its corresponding value is deadline. So till here what we are doing, like for the entire input we are searching for the maximum possible deadline that is given. So here it's 4, so 4 is the maximum deadline that is given. So we will create a result array in result array, and that will be of the same size as that of the maximum deadline that we are stored in a max, plus 1 we will be storing, and then we will be initializing this whole result array with a -1. So int I is equal to 0, I should be less than equal to the maximum value or maximum plus 1, and then I should be plus this, and just initialize this result array with a -1. And yes, till here we have initialized the maximum array. Then we will be creating like a profit and count, like how many job can be performed, that counted, and that will be initialized to 0, and the profit that when the job will be performed, that the profit will be summation of the profit will be stored in this variable. Now then we will be moving in the whole array, like int I is equal to from 0 till I should be less than n, and I should be plus plus, and then we will be traversing like in the result array. From the back of the result array we will be traversing and checking, and we will try to store the value of this given job sequence. The maximum value, the first maximum profit we will be considering, and its corresponding deadline, that like it's 4. So we will be in the result array we will be moving to the fourth position and we will store the 4 value. Okay, means that the first job is done. And if while moving to the second one, it has also a id of 1. uh, it has id of 1 and 4 and 20, and it has a deadline 1. So we will be moving to the fourth. Okay, the first element will be this one, 40 profit, and deadline is 1. So in the result area of this, we'll be moving to the first position of the result area and we'll be storing the 1 value, and profit will be added with 40, means this job has been done. Now we'll be moving to the next, this one. So this one, again it will check for the, in the result array for the deadline 1. If its position is empty, then it will store. If it's not empty, then it will move backward toward the decreasing order. So for that we are just declaring like a j array. It will be from j is equal to arr of I dot deadline. It will be starting from the deadline. It will be starting from the deadline, and it should be greater than equal to greater than 0, and this j will be decremented and it will be checked. If my result, if my result of j is equal to -1, if anytime my result of j is -1, then result of j will be stored with the value of I, counter will be incremented, profit will be added with the arr of I dot profit, arr of I dot profit. And since if this will be done like in the first position only, then we'll be not decrementing the array and going to check whole. So we'll just break it over here, itself, and then we will be it will come out of this loop and it will go for checking of the next job. Okay, so this was the, and at the end what we have to return is an integer array which will contain the first input as a count and the second input as a profit value. So here after this we will be creating an answer array of size 2, length of size just 2, because only 2 elements we have to pass, and answer of 0 will contain the counter value, and answer of 1 will contain the profit value. Okay, and finally it will return the answer. Now we should check, compile and check if there is any syntax error. Okay, it got passed. Now checking for all other test cases, corner condition as well, it will be checked in this. Okay, now test cases, yeah, it's getting passed. Yeah, it's getting passed. So basically in this problem what we are doing, like first we are just sorting this array in a descending order of profit. Then we will be checking for the maximum deadline, so that we have to initialize an array. We will be finding the maximum deadline, then we will declare an array of the maximum deadline, initialize that particular array with a -1. Then we will for the two we have to find just two things: counter of the jobs that will be done and the sum of the profit of the jobs that has been performed. So we'll be traversing for each of the job. Okay, from 0 to n we'll be traversing for each of the job, and we'll be checking if the deadline, like the position of deadline in the array result array, if it's -1, then we'll be storing there itself the counter value, the I value, and sum and counter will be incremented. indicating that the particular job has been done. If the if my j of I is not equal to -1, then it will be like decrementing its position, and first of all it is finding at the fourth position, then it will be finding third, 2, 1 and 0, till decrementing order it will be finding in this array. And thus all the result array, all the value of the sequence will be stored in the result array. And if I have been told to pass the counter, like a number of job has been performed with a maximum profit, so I'll be giving the output as a count. If I'll be told to pass the profit, then I will be returning the profit value. And if it will be told to give the sequence in which the job has been done, so I will be returning the result array, that is storing my result array, that is storing my I value, that is the sequence of the job that has been performed. So in this program we are just finding all the elements necessary or that are always told to find in the job sequencing problem with a greedy approach. So this was about the greedy approach job sequencing problem. And in this you can see, like we are like sorting the array. So arrays dot sort, so it time complexity will be order of n log n for sorting. Then we'll be checking for order of n and then something like m. uh, uh, so order of n into m, we can say the time complexity. And the space complexity we will be using in integer array of result of size m, where m is the maximum number of deadline. Okay, so this was the time and space complexity of this job sequencing problem. If you have any doubt, just put it in the comment section, and do hit the subscribe button. Thank you.